We were talking about jogging the robot, and we went around and looked. So we jogged the robot in what we refer to as a coordinate system, right? And what coordinate systems did we talk about? What the first one we talked about? Talked about joint. Okay. What's the next one we talked about? Yeah, this is given different names. We'll call it world. It's called world in document, but some robots call it Cartesian. Some of them call it base. But those are all the same thing. And what's the third one we talked about? Yeah, tool. And what's the fourth one we talked about? So joint, tool, world, and joint, world, tool, and user are the order that we talked about. And it's covered in that document y'all supposed to be reading. Have y'all even looked at that? Pulled it down, looked at it? So what is joint? That's where you are responsible for jogging each degree of freedom, right? Okay. We have 6 keys on the robot for the KUKA, the FANUC, the Motorman. The ABB uses a joystick. It's a 3-position joystick. So you're responsible for moving each axis. Then we have whirl. What's whirl? Well, the robot don't do anything. The robot's a big chunk of metal that's got a bunch of motors. What's the parts of a robot system? Well, we got the robot. It don't necessarily have to be an arm. It's going to be a robot, though, right? What else is part of the robot system? Axis? Well, that's the robot. The robot, what consists of axis. So as soon as I say robot, that takes care of the servo motors, the axis, all the other kind of stuff. So what's the parts of a robot system? So if I go over and look at that robot, it's got at least 4, all of them's got at least 4 different things that make up the system. That's part of the robot. Robot. When you say robot, it's that big old metal thing and everything's attached to it. What else do I have over there? I got a controller. That's exactly right. What does the controller do? This guy is the guy. It's the one that's running the system. This is like your brain. So you got your arms out here, right? You understand. And then you've got your controller. What is your controller? That's your brain, right? You understand. Your brain is what's doing everything. Y'all understand what we're saying? This is the guy. This is the guy. So when you program the robot, when you teach a robot, you're actually putting the program in the controller. The controller does everything, right? You understand? So when you select a system, you're selecting the system that you're going to jog in. You're telling the controller which system you're going to jog in. And then the controller is responsible for controlling the axis. The robot's not responsible for controlling the axis. The robot can't even control. It's like I come up here and jerk my up. I say, what's responsible for moving my arm? And you say your arm. Right? You understand? That's not what's responsible for moving my arm. It's my brain. It tells my actuators. What's my actuators? That's my muscles to move. When they call people brain dead, they can't do anything, right? You understand? Because they've lost their control. So the controller is responsible for moving the robot. So when you switch it into whirl, the control is even on joint, the controller is moving the robot, but you're telling the robot which axis to move. When you put it in whirl, you're not telling the robot what axis to move with the controller. The controller figures out what axis to move. It figures out the direction. It figures out the speed, right? You understand. So in world coordinates, what does that mean? So when I tell the controller that I'm going to jog in world coordinates, what does that mean?
Yeah.
Well, when we do that, we're going to switch over to these guys right here. This guy right here. This is what we call a frame. So we're going to jog it in a three-dimensional box, right? You understand that? So we're going to jog in. When we switch over to the world, we're switching over to a frame. And we have three frames. Joint jog does not jog within this frame. We call this a frame, but actuality is a box, right? You understand? Okay. So now the robot would appear to be a rectangular robot, but it's not, right? You understand that? It's just that's what we're jogging. So when we switch over to world, we're not concerned with a joint, we're concerned with a direction within that frame. And what's the three directions we can move the robot? Call them what? X, Y, Z. Do y'all understand X, Y, Z? Oh yeah, okay. So what's Z? Up and down. What's X? Not side to side, we'd say in and out. Okay, y'all understand that? So this is what we're looking at right here. Here's Z, here's X, and here's Y. Everybody understand that? We call this the right-hand rule of robotics. This does not establish the Cartesian system. The system has been around long before robotics was around. This is what we determine the direction of the Cartesian system, right? Y'all understand what we're saying? So which one, what's my thumb? That's Z. Okay. What's this pointing finger right here? X. We call this the index finger. And then this guy right here, it moves us left to right, right? Everybody understand that? Or side to side, whichever one you can say. And our fingers point in the positive direction if we position ourselves correctly. So if we position ourselves behind the robot, at where the power cables and everything come into it, and point toward the robot, or if we get in front of it and point away from the robot. Everybody understand that? And then roll, pitch, yaw. When we're talking about roll, pitch, yaw, we're talking about, so X, Y, Z is talking about positioning the robot. Roll, pitch, yaw, we use that to position the tool. Now, of course, the robot's going to move what axis it needs to move. So when I'm jogging, I'm concerned with what we call the orientation axis. When I'm doing a joint jog, we're concerned with the orientation axis and the positional axis. When you switch to a Cartesian system, the robot determines which axis to move. So sometimes it might move the orientation, sometimes it might, because what it's going to do, these are going to maintain the orientation of the tool. And these are going to move the tool around the tool center point. And that's the end of arm tool. And that's what what's the tool center point?
Robot at face plate.
Yeah, but what is it? I You're telling me where it's at. But I say, what type of car you got? Oh, well, I'm parked out there in the third spot from the left. Has nothing to do with the car. Right? Where's the headlights on your car? Well, I'm parked out there. What's the tool center point? Well, yeah, that's the point we're trying to position, right? You understand that? It does not have to be on anything. In fact, I said on our tools, if I was going to set the tool center point on our grippers, I would set it right there. And that's not on the tool. That's in the center of the tool, right? Because that's what I'm trying to position. I wouldn't want to move the robot to over here, or I wouldn't want to position it there, position it there. I'd want to position it right here, right? You understand that? So that is what we call the world jog, or Cartesian, or rectangle, or base, or XYZ. These robots call this different thing. We're going to call it world jog, because that's what most robots call it. The origin is located where? So y'all understand the origin. So a frame has an origin. Okay. Everybody understand that? And a lot of robots record their position relative to a frame. The T-spin controller used to jog axis 1, 2, and 3. Jog the robot X, Y, Z relative to the center of the robot base. The world frame is built into the robot. You cannot change it. And function of keys vary with the robot. So X, Y, Z, all robots are going to do exactly the same. They use the right-hand rule for robotics. But when you get to roll, pitch, yaw, you're going to have to figure out which one does roll, which one does pitch, and which one does yaw. So here's the right-hand rule for robotics. Determine the direction of Cartesian jogs. Everybody okay? And this is yes, we looked at that. Roll, pitch, yaw. We call this a triple roll wrist. And what they're talking about is our way we can do our elbow, our hand. Now what I'm doing, this would be pitch if the tool center point is at the default. This would be yaw if the tool center point is at my default. And of course, this would be roll, right? You understand? Everybody understand that? Now, if my tool center point is set out here, then this will be yaw, this will be pitch, and then roll's the same. And this is the direction of roll, pitch, yaw. Roll's kind of hard to do because it's actually going to do what? So here's roll. This picture's real nice. Tool center point is the point at the end of the arm or free space that the user wants the robot to position. Set at the center of the mounting fledged by robot manufacturers. And of course, we can do what we call a tool frame. So when we set up a tool frame, we're establishing the tool center point. And we'll do that as a class this term. I think it's like the 8th, 9th lab. I don't know, but we'll do it as a class. Tool coordinates, T-spin, we'll go over and look at this today. The T-spin control used to jog axis 1, 2, 3 in the joint coordinates jogs the tool Cartesian to the tool center. Not the robot. Of course, the robot's going to move, but what now our XYZ moves out to the tool. And then roll, pitch, yaw is not going to change. So on all your Cartesian systems, whatever keys you use to jog, roll, pitch, yaw will be the same on all of them. And Are they? They're the same? No, this is relative to, and these are the Kuka, the Fanuc, and the Motorman. And I don't know why I don't have the ABD out there, but I think I do. But and then we have what we call user coordinates. User coordinates, you establish the origin, and you establish the direction of X, Y, Z. So user coordinates is a configurable frame. Tool coordinates is a configurable frame, but we don't determine the direction of X, Y, Z. We determine the location of the tool center point. World frame, it comes built into the robot. Y'all cannot do anything about that.